Okay, so I'm doing this in my kitchen, and there's going to be a little bit of background noise, so just bear with me. But I saw some students really working hard on this topic, and I wanted to post a video for it. So, interconverting number of atoms. I don't think I didn't prepare my whiteboard yet. Interconverting number of atoms and mass of compounds. Let me come over here. File, add image. Add my image here. Boom. Open. Bring it up here. All right, let's go. Sorry, here. Okay. Boom. All right, so this is what I got. Interconverting number of oxygen atoms in 60 gram sample of glucose. That's how many grams of glucose I have, C6H12O6. And so I'm going to come over here, disappear that. My mass of glucose, 60 grams I think it was, right? Let's come back over here. That's right, 60 grams. Okay. Now I don't know, and I'm looking for atoms, right? Atoms of oxygen, which is sort of a far cry. That's O. That's with in parentheses. Okay. That's a far cry from glucose. But I do know this: that for every mole of glucose, I've got 6 moles of carbon, 12 moles of oxygen. I'm sorry, of hydrogen. Oh man, sorry, it's Friday night. 6 moles of carbon, 12 moles of hydrogen, and 6 moles of oxygen. Let me go back and verify that. That's right, you see it, C6H12O6, okay? So I know that I've got for every 1 mole of glucose, I have 6 moles of oxygen, right? And for every 1 mole of oxygen, I've got 6.022 times 10 to the 23rd atoms of oxygen, right? I know that. Okay, and I know my formula weight of glucose because I can look it up, right? My formula weight of glucose, making up a symbol for it, is equal to 6 times carbon plus 12 times hydrogen plus 6 times oxygen, right? And so that's 6 times 12.011 plus 12 times 1.008 plus 6 times 16.00, right? So I'll look this up on my calculator in a second, but let me estimate it first before I do. This is a really, really good habit. 6 times 12 is 72. 12 times 1 is 12. 6 times 16 is 96, right? So 12 plus 72 is 84, plus 96, which is the same thing as 80, plus 100, which is equal to 180, okay? So I'm going to do this now with a calculator, but it needs to be close to 180. I do that because it's so easy to put something in my calculator wrong that, all right, 6 times 12.011 equals 72.066. Okay. 12 times 1.008 equals 12.096. And that's exactly 96, right? Or not exactly, but 96.00. Okay. Plus 96. I'm going to add those up now. Plus 72.066 equals 180.162. 180.162. All right, that's perfect. That's the formula. It's 180.162 grams per mole. Okay. Now I think I'm ready to go with this. I'm going to go. I'm lost in. I need some more space here. So I think I'm ready to go. What I'm going to do now is I'm going to say I've got the grams of glucose. Okay. I'm going to convert that to moles of glucose, right? by dividing by the formula weight. This is the mass. This is 1 over formula weight, right? Because this is the reciprocal of formula weight, right? Because it's moles per gram, which is the upside down of that. All right, and then I'm going to convert that to moles of oxygen, right? Watch this. You've been doing this all semester. So moles of glucose for moles of oxygen, right? And I'm going to convert that from moles of let's keep this in red. Moles of oxygen to atoms of oxygen, and I'm going to be done then. Watch this. This is moles of to atoms of oxygen, and then I'll be done. Okay? Can you see grams of glucose are going to cross off? Moles of glucose are going to cross off. Moles of oxygen are going to cross off, and I'll be left with atoms of oxygen, which is exactly what I wanted. Right? Okay, so let's put the numbers in there now, and then we'll. Let's also keep going. This was a mole ratio. Right? That's what that was. And this was Avogadro's number. I don't even know how to spell it. Is it Avogadro's number? Right? Okay, so let's put the actual numbers in there now. And they are, I think it was 60. 60 grams. 60.0 grams. And the formula weight was 180.162. 180.162. Right? And moles of oxygen there were 6 moles of oxygen for every 1 mole of glucose, right? And then there's 6.022 times 10 to the 23rd atoms of oxygen for every mole of oxygen. Okay? So essentially what I'm going to do now is I'm going to multiply 60.0 times 1 times 6 times 6.022 times 10 to the 23rd, and I'm going to divide by 180.162 times 1 times 1. Right, and that'll give me my answer. And the units are going to be in atoms of oxygen. Okay, so let's do that now. I already have 180 in my calculator, so I'm going to take the inverse of that times 60 times 6 times 6.022 times 10 to the 23rd equals, I got 1.203, 1.2033 times 10 to the 24, right? And now I got to say how many sig figs do I have? I have 3 sig figs here. That was exact, so it doesn't matter. That was exact, so it doesn't matter. 4 sig figs here. Although I looked it up, we can look up 5 even, right? And 6 sig figs here. So 3 times 4 divided by 6. 3 is the smallest number. I can only use 3 sig figs here. So this is going to have to be reported as 1.20 times 10 to the 24 atoms of oxygen. All right? Okay, so a little bit over-explained there, yes, I admit. But in a video, of course, you can go back and watch it again. I encourage you to do that. If it doesn't make sense, I encourage you to go back and predict what I'm going to say next. That is, go, edge the... my vocabulary is totally gone now. Step the video forward little by little and see if you can tell where I'm going. And of course, you're always welcome to ask me for another work example. Happy to do it. All right, hope that's helpful.